Good morning, everyone. This is Shilpa, an assistant professor from the Department of Mathematics. Today, I'm going to discuss about the hypothesis testing. First of all, what is this hypothesis testing? So many of us have an idea of what is meant by hypothesis testing. So usually we use this hypothesis testing in statistics. So whenever we have any assumption, so whether our assumption is correct or wrong, how much percentage it is true, so how much confidence we are correct, so all those things can be discussed through the hypothesis testing. So this video I'm making the content regarding for the exam point of view, so I hope this video will be some useful for you all. Now we discuss about the small samples. So as I said, depending upon the samples we are going to categorize the tests. So here in small samples, it will be n less than 30. Many of the students will have a misconception that which one you have to use, whether you have to use z-test or t-test. Z-test. Z-test is used when your sample is large sample, and t-test you have to use when your sample is small sample. So depending upon the sample size, we are going to characterize whether it is z-test or t-test. So if your sample size is a small sample, and if you are having a single mean n less than 30, then step 1, same, null hypothesis H0. How many samples we have here? Only one sample we have. So it will be, what is the null hypothesis? Mu equal to mu naught. Next, step 2, alternative hypothesis H1. This is very, very important. Why? Because depending upon the two-tailed or one-tailed, we have to tabulate the values which will be provided in the examination hall directly to you. Do not carry any tables with you. So here mu greater than mu naught, or mu less than mu naught, or mu not equal to mu naught. So these first two things comes under one tail, and this one comes under two tail. This comes under two tailed. So here once again, step 1, null hypothesis H0. So as we have single sample here, we write it as mu equal to mu naught. Step 2, alternative hypothesis H1, mu greater than mu naught, or mu less than mu naught, or mu not equal to mu naught, depending upon the data. Next, step 3, level of significance alpha. This is 5% if not mentioned. Step 4, test statistic. So there we have used z equal to x bar. Now here we are going to use t. This t test is also called as student's t test. T equal to x bar minus mu by s by root n minus 1. X bar minus mu by s by root n minus 1. This is the formula. So here x bar denotes mean of sample, mu denotes mean of population, S denotes standard deviation of sample, N denotes sample size. So t equal to x bar minus mu by s by root of n minus 1. So you may having a doubt why we are using this n minus 1. So why? Because here we are going to include one more terminology called as degree of freedom, that is nu. Nu equal to n minus 1. Degree of freedom nu equal to n minus 1. And next, step 5, conclusion. So as we have for the large samples, we have the tables, we have to remember those values. But whereas coming to the small samples, these values are provided in the table, critical value. So here we are going to tabulate the value in such a way that as we are having degree of freedom nu equal to n minus 1, and if your tail is a two-tail test, then your level of significance alpha will be considered as alpha by 2 for two-tailed test. For one-tailed, it will be only alpha for one-tailed test. So depending upon the tabulated values and depending upon the tails and degree of freedom, we are going to tabulate the value. And as here also we are going to compare the calculated and tabulated. If calculated is less than tabulated, then we accept null hypothesis H0. And if calculated is greater than tabulated, we reject null hypothesis H0. So once we'll have a recall of what we discussed here. So here we are discussing about a single mean t-test because the sample is small. And here step 1, null hypothesis H0, mu equal to mu naught. Step 2, depending on the problem, it may be any one of the tail. Step 3, level of significance alpha. If it is not mentioned, we consider it as 5%. Step 4, test statistic t equal to x bar minus mu by s by root of n minus 1. And here one more concept called as degree of freedom nu, that is n minus 1. And step 5, conclusion. So again here we are going to go with the comparison between the calculated value and the tabulated value. So this is about a single mean. So when you have two means, or even you have two samples, N1 and N2. So your t-test, from at this point of view, many students will be having a doubt whether we have to use pair test or difference of t-test. So usually when we use this pair test, whenever we have any comparison between the means, here when you comparison between means, in this case you have two means but sample is single sample, only N1, only N. Once again, when you have to apply pair test, whenever you are comparing between the means of a single sample. So a simple example. So whenever we go for a sugar test, so we go with the pre-lunch and post-lunch. So what we are doing here, we are comparing the results of your blood levels before the lunch and after the lunch. Or if we go for any drug result, what is the comparison between the before the drug and after the drug. So in such type of cases, we use the paired t-test, and if your sample is smaller sample. And coming with the difference of test. So here in this case, difference of t-test, here you will be having two samples. Sometimes you will be having both the samples will be of same size, but don't get confused here. Okay, and here also you have two means. So difference of t-test, difference of means, two samples, n1 not equal to n2. Sometimes n1 may be equal to n2 or n1 equal to n2. So don't have a confusion here. If n1 equal to n2, I'll use paired t-test. So read the problem carefully once again and then you go with the which test you have to apply. Now here we will go with the procedure. So whenever I have single sample with two means, I'm applying paired t-test. Two samples, that means n1 and n2, I'm applying difference of t-test. So here step 1, null hypothesis H0. So I'm having two means here. So here it will be mu1 equal to mu2 and here also it will be mu1 equal to mu2. That is the reason many of the students will get confused between both the tests. So avoid the confusion. So next, alternative hypothesis H1, mu1 not equal to mu2 and here mu1 not equal to mu2. So in this case it will be a two-tailed test. Step 3, level of significance alpha. If not mentioned, consider it as 5%. And step 4, t equal to d bar by s pi root n minus 1 or root n. Here t is equal to x bar minus y bar by s into root of 1 by n1 plus 1 by n2. In paired t-test, the degree of freedom nu equal to n minus 1 and here degree of freedom nu equal to n1 plus n2 minus 1. Step 5, conclusion. So same thing, compare the results here with the tabulated value. If t calculated is less than t tabulated, we accept. If t calculated is greater than t tabulated, we reject. Once again, we'll discuss here. If you have a single mean and if you have in single sample, if you have two means, then you apply paired t-test. Single sample, two means, paired t-test. Two samples, two means, difference of t-test. So here in both the cases, the null hypothesis and alternative hypothesis notation will be same. These are only the notations. In order to avoid the confusion, here we are denoting the all the wordings with the notations. So here step 1 mu1 equal to mu2, then also mu1 equal to mu2. Step 2 mu1 not equal to mu2 depending upon the problem. Next step 3, level of significance. If not mentioned in the problem, we consider it as 5%. And step 4, the test statistic where we do the calculated part, and step 5, the conclusion. So this is about the t-test. Okay, so up till now we have seen the problems based upon means, based upon proportions, based upon differences, all those things. Okay, if in our problem we don't have these type of wordings or we don't have any things related with the mean, proportion, or those things, and if we have only the variances, if we have only the variances, then we use the test called as F-test. So in F-test, we compare the variances. So whether as in Z-test or T-test, we compare the means. Here we compare the variances. So usually the variance is denoted with sigma square. Variance is denoted with sigma square. So here, as we are comparing the variances, here in F-test, we have two samples. In F-test, we have two samples. So we will go with the procedure. Step 1, null hypothesis H0. So here the notation will be sigma 1 square equal to sigma 2 square. Step 2, alternative hypothesis H1. Sigma 1 square not equal to sigma 2 square. Step 3, level of significance alpha. Step 4, test statistic F equal to greater variance by smaller variance. So depending upon the variances, depending upon the formula, nu1 and nu2 will change. So if your formula is S1 square by S2 square, then nu1 will be N1 minus 1 and nu2 will be N2 minus 1, F equal to. And if your formula is F equal to S2 square by S1 square, then in this case, your nu1 will be N2 minus 1 and nu2 will be N1 minus 1. The last step, step 5, conclusion. F calculated, conclusion means critical value. Critical value, here in this critical value, we tabulate the value. F calculated and F tabulated. If F calculated is less than F tabulated, then we go with the acception of hypothesis, and if F calculated greater than F tabulated, we reject the null hypothesis. Again, we'll discuss once we have a recall here. When are we going to use this F-test? Whenever in the problem, if we have the concept of variances, we are comparing the significance of variances, then we use the F-test. So here in F-test, the first step, as we are comparing with the variances, H0 will be sigma 1 square equal to sigma 2 square, and alternative hypothesis will be sigma 1 square not equal to sigma 2 square. Level of significance depending upon the problem. And next, step 4, test statistic F calculated equal to greater variance by smaller variance. So depending upon the formula, the nu1 and nu2 will change. And then conclusion part. So up till now we have discussed about the t-test, z-test, proportion and f-test. So you might be having a little bit of idea of at least now which test you have to apply where. Okay, now you may have it out. If you don't have all this type of things, if you are having any about the nature, about the habits of a person, all those things, then we use a very important test called as chi-square test. So in this chi-square, we have two types, goodness of fit and attributes. So the formula for chi-square is summation of, see my brackets, OI minus EI whole square by EI. So see the brackets carefully. I am putting the brackets for the complete numerator as well as the denominator, and the summation is for both numerator as well as denominator. So summation of y minus ei whole square by ei. Chi-square equal to summation of y minus ei whole square by ei. So in this case, the degree of freedoms will change according to the distributions also. If your distribution is a binomial distribution, then degree of freedom nu equal to n minus 1. And if your distribution is a Poisson distribution, then the degree of freedom equal to n minus 2. And if your distribution is a normal distribution, degree of freedom nu equal to n minus 3. So do not get confused. By seeing the data, you have to apply a t-test. So here, the main thing in chi-square test is calculation of expected frequencies. So this is the main thing where the students find difficult. So read the problem carefully, identify what you have to calculate. So whether you are given a normal frequency table or a distribution problem, so depending upon that, the calculation of expected frequency will be different. So this calculation of expected frequency for goodness of fit and for the attributes will be changed. So goodness of fit, depending upon the problem, it will be dependent. So here we'll have the procedure first. Step 1, null hypothesis H naught OI equal to EI. So here we are comparing between the frequencies of the observed and expected frequency. So that is the reason we note it with OI equal to EI. Step 2, alternative hypothesis H1 OI not equal to EI. Step 3, level of significance alpha. Step 4, test statistic. The formula is given by chi-square equal to summation of OI minus EI whole square by EI. Summation of OI minus EI whole square by EI. This is the formula. Do not make mistakes when you are solving the problem. Many of the students make the mistake at this step. They just write it as summation of OI minus EI whole square by EI. This is a wrong formula. This is the correct formula. So have a clear picture of which formula you are using whenever you are solving the chi-square distribution. Step 5, if the problem is a goodness of fit, then the degree of freedom nu equal to n minus 1 for goodness of fit problem. So conclusion. Next, critical value. Chi-square calculated and chi-square tabulated. Less than calculated, accept it. Greater than calculated, reject it. Once again, we are comparing here the frequencies. So observed frequency is equal to expected frequency. This is a symbolic notation. OI equal to EI. Even if you want to write in the word form, you can write it. It doesn't matter. But notation means many of the students can have an idea without writing in the words. So that is the reason we are mentioning the notations here. So the formula is summation of OI minus EI whole square by EI. So see the differences here. Both the formulas are different. So do not make the mistake by writing this formula. Next, step 5, the conclusion. Now, if your problem is a problem of attributes, so how to identify the problem, whether it is an attribute problem or not? So here when you have an attribute problem, go with the row total and column total. Row total or column total. Row total or column total. If both the row total or column total are equal, then it's a problem of attributes. Row total or column total are equal, then it's a problem of attributes. So here the procedure is this one and the same, but calculation of expected frequency will be easier in this attributes. So depending upon the contingency table, for example, I'm giving a small example here, A, B, C, D, I will calculate the expected frequency of A. A plus B into A plus C by total frequency A plus B plus C plus D. So for each and every cell, I need to calculate the expected frequency in this model. So now tell me expected frequency of B is what? B plus A into B plus D by A plus B plus C plus D. Expected frequency of C, C plus A into C plus D by A plus B plus C plus D. Expected frequency of D, D plus C into D plus B by A plus B plus C plus D. So this is the procedure of your chi-square test. Attributes and goodness of fit. So now I hope you have an idea of which test to use where. So a small recovery of what we have discussed. So first, what you have to do, identify the sample size. Then you observe whether means are given, proportions are given, or variances are given, or attributes are given. That means, or that is frequency. So depending upon these models, you use your test statistic. So first identify the sample, then you identify which type of data is given to you, whether it is of means, proportions, variances, attributes, or frequency. Then use your test statistic according to the given data. Next, conclude. So this is a small identification of how to identify the problem, which test you have to apply. So thank you everyone. Hope this video is helpful for you. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.